Welcome everyone. Day 2 of Azure Innovators Hub, Public Sections 2025. Today we have one speaker. That's the first time we meet. I saw the session and looked quite interesting. Uh, Without further ado, I'm going to present to you Samson Amaugo, I'm sorry. Hello Samson, welcome to our session and to our group. We're happy to have you with us. Yes, the stage is yours. You're driving.
Yeah, thanks for having me. And hello, everyone. I am Samson Amungo. I am a software engineer at Green Places and a Microsoft MVP. So let's look at what we are going to be talking about today. So the title of my session is Scalable AI with Memory or Lanes and Semantic Kernel for Distributed Agents. So we're going to be looking at how to use a combination of tools and technologies to create AI agents that are not only stateful but distributed across clusters. And we're going to focus primarily on two technologies, Microsoft Orleans and Semantic Kernel. So let's dive in. So what exactly is Microsoft Orleans? Microsoft Orleans is a virtual actor framework for building distributed stateful apps. So it makes use of the concept of lightweight immutable objects known as grains to encapsulate states and behavior. If you're familiar with the paradigm of object-oriented programming, the virtual actor framework would look understandable to you and easy to relate. Another thing about Microsoft Orleans is that it makes managing lifecycle of grains to be easy. It also helps with concurrency and persistence of actors. So you don't have to worry about the activation and deactivation of grains. Orleans makes all this easy and seamless for you. And also, since it makes use of the single threaded means of execution, you don't have to worry so much about multi-threaded issues or maybe using mutexes and semaphores. You don't have to worry about that because it just makes use of a single threaded means of execution. And it also embodies this pattern of saving states in your grain. So you can actually save data or persist data in your grains. Another thing here is transparent scale out. So when using Microsoft or Lanes, it takes up the burden of, or let's say a bit of the burden of handling how your grains are distributed across the nodes in your clusters. And another thing there is that it also gives you room to customize how you want the scale out of your grains to occur. And if you're a gamer, you probably have heard about the game Halo. Yeah, so Orleans powers the backend of Halo, so it can be seen to be battle tested. It also powers a lot of Microsoft's Azure services. So let's move into the next thing, which is semantic kernel. What exactly is semantic kernel? So semantic kernel is an AI orchestration SDK from Microsoft. It serves as a bridge between your app and tapping into an LLM, trying to bring in all those cool AI features into your app. So that is what Orleans does. If you're also familiar with some tools like LangChain and LangGraph in the Python ecosystem, semantic kernel is similar to that. Another thing there is that it also offers function calling, planning, and chaining. So you can actually like define functions that your LLM can call into, which would make it more capable to perform different tasks. And you can also like chain different tasks to in its execution pipeline. Then another thing we have here is it offers agent orchestration with different patterns still, but this is still in its experimental stage. And so with semantic kernel, you can actually put together different agents to form very complex orchestration patterns based on your needs. Although there's a new framework that was recently created by Microsoft that would be like a step up to semantic kernel, which is called the Microsoft Agent Framework, which we're not going to discuss here. So moving on, if you're a Python or .NET developer or a Java developer, you can easily play around with semantic kernel. You can, install the library in your favorite editor and tinker or tweak it. Then let's look at some of the problems in AI agent systems, right? So here, the first thing we have is state management complexity. So when dealing with AI agents in a multi-threaded environment, handling states can become incredibly complex and hard to deal with. Then the next thing we have is concurrency and life cycle conflicts. So when dealing with multiple agents in a multi-threaded environment, there could be concurrency issues, and the need for mutations and semaphores might be needed. These are some of the problems there. And the next thing we have is agent identity and placement challenges. Determining where your agents will reside and how it can be accessed can be a problem in a distributed environment. And another thing we have here is ambiguity in orchestration scope. So when trying to come up with complex orchestration, there'll be need for you to have a robust framework. Then the next thing we have is Orleans as the solution. And the first item here is structuring each agent as an Orleans green. So when you structure your agent as an Orleans green, the green can be seen to be a self-contained unit and is independent. You can have that model in your head when interacting or when writing out your code that this agent or this green is an agent, so it's independent and it can also be seen to be self-contained. Then another thing we have here is life cycle is automatically managed. So you don't have to worry about the deactivation activation of grains. This whole life cycle is just handled seamlessly by Orleans. Another thing we have here is states can be persisted and rehydrated seamlessly. So if you model your chart history as a grain state, then it can be easily restate, is persisted, becomes seamless because you just start writing your code using the Orleans style or methodology of um, object-oriented programming in terms of the grains in Orleans. And the final thing we have here is cluster-aware grains. So um, Orleans takes care of how your grains are placed across the nodes in your clusters, and it also helps them to communicate. So the whole plumbing and cross communication is handled by Orleans. Now, what would happen when you combine Orleans and semantic kernel? So what we have is stateful AI agents at scale. You're able to easily and seamlessly create AI agents that can scale in your cluster seamlessly. Another thing we have is durable and distributed. This just taps into the Orleans design. And it's also safe because you don't have to worry about concurrency issues. It's single threaded. And you can also use both of them to create complex AI orchestration workflows. Then is demo time. Uh, so this is the app I'll be demoing. It's a chat-based file utility app that handles basic file manipulation and conversion, such as converting from a PNG file to a PDF file, and also converting from a PDF file to a PNG file. And the last feature here is it could merge PDFs together. So I think let me talk about the objective. So the objective of this demo is to illustrate agent creation using a green where you model an agent to be a green, like an agent per green. Each green is seen as an agent. I'm also going to illustrate the concept of contextual function. So, okay, let me demo the app if I get back here. So this is the file utility app. I called it, oh, let me turn on my server. See, turn on my server and see. Okay, so I'm using Aspire to bootstrap this web application. The front end was designed using Next.js, and the back end was designed using ASP.NET Core. So let me load the app. Let me hide this. So let me instruct this app to convert an image to a PDF. So I'll say convert this image to a PDF. And then I'll select the image that I want to be converted. Then I'll send it to the model and I'll wait for a while. And yeah, so it has given me a response. The image has been successfully converted to a PDF file. So when I click on this downloadable link, I should be able to see the converted image in a PDF format. So now that you have an idea of what this app does, let me just give a summary of the whole flow in the back end between the front end and the back end. So let me get back here. So basically what happens is in the front end, let's say I want to convert a file from one format to another. The first process that goes on is that the file is uploaded to the back end and of the file is sent to the front end. And then the front end attaches the ID of the file to the text, the prompt that you typed in, and sends it using WebSocket, which is powered here by Signal R, to the Signal R hub in my backend. And then the Signal R hub is connected directly to an unleased green. So for this demo, I'm modeling every single chat room as a green. So the Signal Hub sends it to an unleased green, and the unleased green communicates with semantic kernel orchestrator, and the whole LLM stuff goes on. So here in the semantic kernel orchestrator, it uses here I'm using an Open AI GPT 4 point, I think GPT 4.1. I'm using the LLM model to understand the semantics of the prompt and select the right tool that should handle the file conversion. So it does the whole processing and sends back the ID of the converted file via WebSocket to the front end. And from the front end, you can click on it and see the converted file. So this is just a brief summary of the flow. So let's get to the code and see what the code looks like. Stop all. So this is my code base. I'm going to start from the app host. Since I'm using Aspire, let me just explain what is going on. So I'm using the Aspire tool to bootstrap all the tools needed. So here, this is how I'm setting up the Orleans integration. And then this is where I'm defining some of the API keys and parameters needed for my model. And here is where I bootstrapped my ASP.NET Core API. The replica is not needed for now. Let me uncomment this. Let me comment this, I mean. Then I also used Aspire to stitch together my front end to this whole process. Then let's get to the API. So start from the program. No, here is not so important, but this is why I added the OpenAI client to my service integration here. And then this is where I also added, because I'm using an embedding generator as well at some point. This is where I added the client to access it using dependency injection. This is where I added my kernel for semantic kernel. And I'm using Redis as well. If you can remember here, I used Redis here as my cache. So let me go back to my API. So yeah, this is just the normal bootstrapping of this where I handle authentication, which we're not going to talk about. I'm using Clark Auth. It's a third-party authentication service. So let me get to the main part, which is the hub and the green. Well, we'll start from the hub. So when I open the hub, this is the method that sends the message to the model for the whole conversion process to take place. So I check if the user is authenticated. If the user is authenticated, I persist the chat history to a green. If the user is not authenticated, I just I send the message to the green, the file ut green, which is the agent. So this file ut green here is an agent. So the file ut green handles the whole chat stuff, the whole conversion of the file, and at the end I save the chat history here. Then this is where I handle exceptions. But yeah, so not so much going on in the hub. So let's get to the green and see what is going on. So this is the file ut green, which is my agents. You can see I have a couple number of functions of different things, different functionalities. Like this one converts from PDF to an image. This one converts from an image to a PDF. This one handles merging of PDFs. These are just functions that I'm annotating or I'm marking with this kernel function. So this attribute, this kernel function attributes just marks my method and exposes them to semantic kernel for the function calling feature that it supports. And the file ut green is a green, just a semantic, is a Microsoft Orleans green. And where is that place coming? Okay, so let me scroll down to where I initialize the green. So this is where I did it. This is where I did. Excuse me. So in this unactivate async method, this is where I set up the whole semantic kernel integration. I bootstrapped the agents and the LLM functionality. So here So what I'm doing here is that I am converting. I'm using the this keyword to convert this entire green to a function. I'm exposing all the functions in this green to the semantic kernel as a semantic kernel plugin. So I'm using a this keyword to make that possible. And then this is where I initialize the chat completion agent, and then I instantiated it and hooked it up, defined it here as an agent. So this is where I gave it an instruction. I said you are a helpful file utility agent that performs some file conversion workflows using the available tools. Then this was where I was like, telling it to always return or give me back a response in a particular format. Um, and also the agent, the chat completion agent also allows you to like set the format in which you want the model to return a response, because you want to actually pass this format and send it to the client in a way that the client will understand. So that's why I had to like set the response format to be this custom defined type that I defined here. Yeah. So um, that is just a brief summary of this. This is where the whole agent stuff, this is where the green is seen as an agent. It happens in this onActivate async method. These other greens, they are just for data persistence. So I'll not really talk much about them. I'll focus a bit on the file util green. So now I've exposed I've exposed all these methods. Anyway, the methods that are being marked with the kernel function and the description attributes. I've exposed them to the LLM by using this keyword. So yeah, that is it. Then there's one other feature that I want to talk about. So now that we have seen how you're able to like map, or yeah, how now you have been able to see how to like model a grain as an agent. Let's now look at the next thing, which is the contextual function. But before I talk about the contextual function, execute, let me run this survey again, and then we'll take note of the current token consumption for this for the current state of this green. So let me run this survey again. Um, okay. So now I'm going to give it a clean prompt. I'll say convert this image to a PDF. I'll select the image, and then I'll send it to the model while I wait for a feedback. So it has given me a response. Now let's look at the token consumption at this point. So I'll go to my Aspire dashboard. I'm looking for the API service. Let me just search for tokens. So here I can see that the total token consumed is 893. And why lots of tokens are being consumed is because anytime I'm sending a prompt to the LLM, it broadcasts all my available functions, both the relevant ones and the ones that are not relevant for the prompt at hand. It sends everything to the LLM. So I'm consuming more than the necessary tokens. So what contextual function does is that it makes use of an embedding. It passes your text, your prompt, and then only uses a text embedding to like only select the required functions for your particular prompt. And you can also customize it to maybe to have a limit, a threshold on the amount of functions or tools that can be broadcasted to the LLM. So now let me take note of this. Let me pen it down. So currently for the prompt called convert this image to a PDF, we are consuming 800, right? We're consuming 893 tokens. 893 tokens. That's what we're consuming. Now let me turn off my server again. And let's look at the other branch that explains or talks about contextual functions. So let me check out the branch. Smart checkout, apply. Okay. So now I am in the other branch, my second branch called contextual functions. So let me open it. Let's look at the green and see what is different about this green. So when I open the file util green, it's almost the same thing. The only thing here is that I'm making use of an embedding generator here. So this embedding generator is what converts all my function descriptions to an embedding, so that anytime I prompt, so if I scroll down, this is where I'm using the vector store. I'm using an in-memory vector store to save all my functions, all my function embedding descriptions. So here I can customize it to based on how I want. But currently I'm saying regardless of your broadcast or similarities found in matching my prompt to the function requirements or the number of available functions that suits it, just max it to 5 functions. So if I have 10, 20 functions available, it only like constrain it to just 5. So it looks for the top 5 relevant functions and broadcast it instead of broadcasting all my functions or tools to the LLM, thereby using the amount of tokens I'm consuming. So I had to write a custom function here. So what this function does is that it uses reflection to get all the descriptions of all my available functions and returns the function name so that the LLM or the embedding can be able to find the closest match in terms of similarity. So now, this is just the higher level explanation of this, but it uses reflection to select all the marked tools or functions. So now let's run the survey again and run the same prompt and see how much tokens we are going to be burning. So let me type the same prompt, convert this image to a PDF. I'll select the image. I'll send it to the model. That's giving me a response. Now let's look at the amount of tokens that we are consuming or burning. So let me go back to my logs and just type tokens. So you can see the total number of tokens here is 621, and this is way lower than 893 that we had initially. So that is just the summary of the demo. I just wanted to talk about how you can model a grain as an agent and also make use of contextual functions to reduce your token consumption during broadcast. Um, so yeah, so let's look at the conclusion. The combination of Microsoft Orleans and semantic kernel can reduce lots of AI agents. So feel free to check it out. If you have any question, also, you can ask me now. You can also look at these references as well, you know, so you can look up on semantic kernel and Microsoft Orleans. You can also use this to join the community for Microsoft Orleans and semantic kernel. And thank you for having me. You can connect with me on X. On my handle is swagblooms on X. My blog is swagblooms.com. On LinkedIn as Samson Amugo. If you have any question, feel free to ask me.
Amazing. Thank you so much, Samson. I was really amazed by the presentation. It's the first time I've seen this project or Lean's project. I have a question. So we can just just so easy deploy on Azure Web Apps or container apps, just like a normal .NET project, right?
Yeah, sure, sure.
And the concept of grains is something that is native to Orleans project to represent entities that, for example, could be your agent in our case, your LLM.
Yeah, yeah.
Okay. Uh, Let me ask you this: do you think that someone with medium developer expertise could get easy on the Orleans project, or it is a project that needs to be deeply immersed into .NET developing? What do you think? Is it an easy adoption? Is it something difficult? What's your
No,
take?
it's not hard if you already have like experience with the object-oriented programming. It's easy for you to adopt. Like the concept of the grain model is not new to .NET. There are languages that actually embodies it by default, like Erlang. That embodies this virtual actor model. So I think in the .NET ecosystem, there are two popular. We have I think Dapper framework also has this grain feature as well. But I'm kind of used to the Microsoft Orleans framework.
Great, great.
Yeah,
Amazing integration from Samsung. Thank you so much for being with us. I will find you in the social and hopefully we will have you with us in another session. Thank you so much, my friend.
yeah. Thanks.
Have a great one.
All right. Bye.
Bye bye. Great. I can see we have Vasev with us already for the next session. Allow me to just uh, play a small uh, intermission and we will be back very soon. Thank you. And we're back. Azure Innovators Hub Public Sessions 2025. Thank you everyone for joining session 2 with Vasdev Guliapoli. I hope I spelled it correctly. Hello, my friend. How are you?
I'm good. How are you doing? And you spelled it almost there.
Oh,
It's,
I was sure about it. Yeah. Can you help me how it is spelled? Your name? How do you
it is
spell it?
Gullapalli.
Gulapali. Yeah. Okay. Okay. I use the Western um yeah syntax.
Yeah, close
So
enough,
what
you know.
what are you going to present to us today? What's your session here? Can you tell us a few
Yeah,
words?
sure. I'm going to go at a high level on how to design the platforms so that they are resilient with some predictive assessment on, hey, I'm predicting that during this time, your workloads will be going to increase with some AI context there. How to build resilient platforms at scale. That is what I'm going to talk about.
Yes, very very useful, especially for the ops teams and infrastructure. This is something really really useful. All right,
Yes.
so I think I will leave the stage to you. You can tell us all about yourself and go on with your session. Thank you so much for being here with us today. We are looking forward to hear from you.
Thank you. It's a pleasure. Hello, everyone. This is Vasdev Gullapalli. I'm a senior staff site reliability engineer manager at Qualcomm. I'm here to talk about how to design a platform which where we can predict and design a resiliency platforms at scale. I'm going to give some real world example strategies which I have implemented at Qualcomm, so that probably you can also consider them when architecting a platform at your end. Agenda, as I said, we'll discuss on today's world's scalability challenges, what sort of solutions we can apply to address those challenges, what is resilience engineering, how we can adapt some of the latest and greatest technologies out there in market to build the platforms accordingly. Um, Zero downtime is something which is popular nowadays. Folks call it as near zero downtime. So when you're designing a platform or your application, what sort of things you can consider to ensure that there is not going to be downtime, like zero downtime, which is key. But it is challenging as well when you're architecting the application. Predictive intelligence, this is getting popular, at least in Qualcomm. How can we predict the workloads? How can we predict on the next hour user traffic going to be, so that we are ready, the application is ready upfront? How to anticipate the issues, how to optimize the platforms, they're all tied into that predictive intelligence. With that, what is the looming problem crisis right now, right? Let me take the recent AWS service interruption, right? We know AWS is pretty popular across the world. We hardly see service interruptions on these popular service based companies nowadays, right? But we ran into a service interruption. Based on the media articles, the interruption was due to DNS, and it is also tied with DynamoDB backend, right? And the interruption is primarily around East Coast, one of the availability zones. That's what the media articles talk about. I'm using the media articles as a source of truth because I'm not sure if there is an official announcement yet. So a heavily user system like that ran into a service interruption, right? Uh, how can we avoid that, right? So that's a whole the looming crisis in a way. Is it tied with the revenue stream as well? Probably it is, right? When we are talking about AWS service level agreements, there are a lot of things come into play when we are designing a system like that. In Qualcomm, with my background, I manage, you'll come to know in the next slide what I do, but I manage systems which are the most critical applications, I would say, If they are down, there is a direct impact to the revenue stream or the flagship device launches. So it's a pretty big deal. So we need to question ourselves: is your platform ready? Are you ready? As an infrastructure engineer, as a platform engineer, as a site reliability engineer, or even at a developer level, or designing your application level, right? Because it all boils down to how you design the application. Is it fail proof? End of the day, right? Are you prepared? My journey, as I said, I'm a senior staff site reliability engineer, DevOps engineer, platform engineer at Qualcomm. I wear various hats. Um, uh, so in my journey, I at Qualcomm particularly, I started off as a location services engineer, as a DevOps engineer, where GPS location service on your phone. If you're using a smartphone, probably the build which I released probably is still running on your smart device. So that's how I started my journey at Qualcomm. Then I slowly moved on to SRE, DevOps, IT engineer role, um, where I manage various SCM systems, Git based SCM systems, I would say. So when I say source code management systems, right, it's bread and butter for almost all the companies out there. If that application is down, that means engineering community is down in a way. They cannot contribute the code which they developed. Eventually, it goes down to the CI/CD platforms, build releases. No one can access the source code, which is bread and butter, right, for almost all the companies out there. So that's why these are all considered as gold tier at Qualcomm. If there is a service interruption, we are calling it as a 911, uh, which is a major big deal, right? So that's the journey. I managed Gerrit, GitLab, GitHub, and all the Git-based ecosystem tied with any tools, DevOps tools, or internal driven tools for various things. We have Azure integration for access management, and we are leveraging that for our predictive intelligence. Scalability challenges. So we'll talk about one challenge at a time. So scalability challenges is something which we need to consider heavily nowadays, especially in the AI world, right? With AI, the new use cases are building up, right? Nowadays, it's easy um, with with agent-based solutions, or API-based solutions, or you name it, right? Like the use cases are building. So now going back to the question, is your platform can scale based on these new use cases? Can you predict these new use cases in advance so that you can scale it accordingly? Azure wise, we have auto scaling, whether it is vertical auto scaling or horizontal auto scaling. These are the techniques which almost all the platforms out there should implement, if not already. Bring the piece of predictive at the front. You predict it and you auto scale it accordingly. Sometimes it can be proactive or it can be reactive also. That's okay, right? Because the reactive in the sense, um, all of a sudden you have traffic coming in which you did not predict. That's okay, right? At least your application is scalable reactively immediately to address that workload. Even that is somewhat okay, right? So these are the things you nowadays it is very, very important, particularly with the new use cases which we are seeing out in the market. Now let's talk about triple threat at scale, right? Latency, compliance, and architecture debt. Latency wise, right? You designed a system we are going to talk about one more slide. There is one more slide out there where we are talking about active passive, but I'm going to touch base a little bit here. You have an architecture where primaries are living somewhere, replicas are living out in the market, out in the various geolocations, I would say, right? So when a hit is coming from, when a user hit is coming from one part of the world to the primary, which is living in another part, right? Is it latency livable, right? Like, can the user see any latency driven issues? In that way, we need to design the platform accordingly. Some requests are latency tolerant, some are not. So where is what is your application designed for, right? Things like that. Similarly, when a primary is talking to a replica somewhere in Europe, right, where it is trying to write something to the database, right? Is can the database latency live with it? Like, things like that, it's questionable. So you have to think about it when you're designing a system. This comes up compliance question, right? Some of the countries out there, right, where their data sovereignty is different from where you are located, right? And the citizen, the everything changes. You have to consider all of these strategies when you're deploying something at a geocentric location, right? As an example, if you're deploying something in Russia, deploying something in China, what are their local rules? Can the data transmit between one geographic location to another without having any sort of issues lingering around, right? Is there a proper audit trail going on, right? With the geopolitical concerns or talks going on, right? Do we have an audit trail where the new requirement coming from can come up from geopolitical reasons? Are you ready, right? Your application, you designed your system so that we can address that as well. Things like that should be questioned or discussed while architecting something. Nowadays, we are seeing a lot of monolithic dependencies. Hey, my application is monolithic. That means, all the services are up and running on the same appliance or in the same pod, right? So architecting a system like that or designing a system like that nowadays is challenging, because you're talking about either the vertical scaling or the horizontal scaling. When you're having a monolithic application which consumes a lot of energy, a lot of memory, and the CPU and all. So you have to vertically consider all of that. Nowadays, I'm somewhat leaning towards moving away from monolithic to a container based, segregate that into pieces so that you can have a HA for every single service which you are serving out there. So you can scale up individual service quite easily, because the memory or the CPU or the hardware spec constraints are relatively less when you are segregating the application into multiple pieces, right? So things like that should be considered when nowadays we are designing a system like that. I touched upon a few topics earlier. This is like a continuation to that. Multi-region design, which is needed. Compliance zones, geopolitical reasons should be considered. Microservices, as I said, monolithic applications are nowadays, with the hardware constraints, may need to be reconsidered. I'm not going to say it has to be redesigned from monolithic to microservices. That is not my goal. There are some applications out there which needs to be monolithic, but they still can be scalable. Things like that. If you're designing a system like that, probably it is okay. But given a choice, if you have a choice at hand, consider microservices. But again, there could be some latencies when you're having a microservice A and microservice B running next to each other on different parts, but they have to interact quite often to each other. So latency plays a key role there. When it is a monolithic, all the services are running on the same pod or the host or the VM. So in that way, it is somewhat livable. Things like that should be considered when you're designing a platform. What is resilience engineering, right? Highlight is preventing the outages, right? As in the previous example, we spoke about outage, right? AWS outage recently. We have seen outages left and right across the board. Like lately, CrowdStrike, I think they had a release which interrupted a lot of other services, right? Things like that. See how resilient our platform is, how our engineering is. right? I took CrowdStrike as an example because of the bug which probably they released impacted almost all the airlines out there. So now the question is, the airline community, how resilient they are, right? Yes, you're relying on a product, fine, but how can you ensure that you're not consuming the releases, or you have a way to modernize your engineering so that if issues like this happen, you can easily prevent, rollback strategies. Do you have a rollback strategy? The product which was released, you're heavily reliant on the vendor, but what are we doing from engineering community wise, like our internal community wise, right? Things like that should be considered. And I'm going to talk about blue green deployment, or there are some strategies, canary based releases, where only some part of the community gets the latest patch, and then based on that, if everything looks good, then we roll it out to the more community. We'll talk more about it. Things like that, right? Modernizing the release strategies by bringing some resilience into your development community. That's the key, right? I'll also bring in one other example, like chaos engineering, which Netflix, I think, developed. Things like that, right? Like chaos engineering, they consider it as resilience engineering in a way. If you look at it, right, that's how at least I read it. They create the chaos by themselves. Like, as an example, they hit the pod continuously until it breaks, to understand when it breaks, where it breaks, right? So they design the system so that, these many hits, it comes to one pod, it is going to break at this point, so that's not going to happen, right? How can we put some guardrails around it? Do we need to put um, uh, some throttling at the application layer itself? Throttling plays a huge role nowadays, right? So I'll give another example, like GitHub, right? GitHub has throttling, right? You can only do X number of API requests per user, per service account, or per PAT, personal access token, or per hour, right? You can only do X number of, because that's how they're throttling it, so that their service will be reliable. They provided this throttling information upfront to the user, so user understands it and design their system accordingly, so that they won't run into the problems, right? Whether they put some retries or sleep once they reach that the upper limit, things like that. The service provider, in this case GitHub, is throttling and providing that information to the user community, so user community can adapt, right? In a way, that is also resilience engineering. Throttling plays a huge role in this example, at least. um, yeah, as I said, we are going to talk about the primary multi-primary architecture. Not every application can support multi-primary, because it has its own challenges. Most of the challenges probably come from the database or the caches. Say I'll give you an example, right? Uh, when you have a primary in US, another primary in India, I'm going to use India as an example, and another primary in Europe, right? Say uh, Paris. I know that France in general, so I'm just using that, right? So US, Paris, and India, right? So three locations, three primaries are running. That means that it can consume the writes, right? A write happened on US. How would far most India primary, which is residing somewhere in Hyderabad, say, here it is in San Diego, say, San Diego to Hyderabad to Paris, how can they understand each other quite easily that, hey, a heavy write happened on one geographic location, where the sync should happen immediately, so that other write may not overwrite one another location, so that's the part which it could be challenging. Is your application designed for multi-primary? If not, probably it is okay. If you have designed, or if you appraise the user community that, yeah, rights operation takes time, so in that way user is upfront aware of it. So your user community, your user experience is okay, reasonable enough, right? things like that, right? So for reads, right, your application is designed saying, okay, I have a have a primary, but I have replicas globally. In this example, we have a replica in Paris, replica in Hyderabad in India, right? So is your replica uh, good enough so that it the user number of reads can go to the corresponding geo replica, which is the closest site, and consume the data from there for any writes? Because relatively, in some of the applications, reads are much more heavy higher than the writes. So probably for the writes, user community is okay. Reads, when it is faster geographic location wise, so they can consume the product there itself quite easily. So you design the system like that. So these are the things we need to discuss, bring in the business community, business folks as well, while designing an application, which helps significantly because they have a business level understanding on what is needed, what is not needed. That helps while designing the platform from engineering wise. Disaster recovery, right? This is huge nowadays, right? Um, Mother Nature. Um, we respect Mother Nature. I don't want to be talking about other side of the things, but no, we never know. Disaster can happen anywhere, right? Is your application resilient? What is the recovery point of RPO, right? Without any data loss, how can you bring it up? Do you have a multi-region deployment? What sort of recovery time you're looking for, right? Um, these should be documented, actually rehearsed, documented uh, proactively so that you are ready, right? So one of the exercises which we do at Qualcomm for the crit one is we rehearse disasters, right? So that if the primary is down, we know at which location the primary has to be up, so that the with very minimal downtime or any data loss, we can bring up the disaster. We can become the site accordingly, right? Things like that should be considered. Cloud-based solutions like Azure plays a key role here. If you have an application which you designed, which you have deployed already, but DR is missing, please reconsider it and come up with the ways how to design a platform where you have disaster recovery. Zero downtime, right? I'll take Qualcomm as an example. As I said, I managed all the Git-based ecosystem at Qualcomm, right? So getting a downtime from my engineering community is very hard, because it's a global company and we deal with a lot of flagship devices launches left and right every single month. When we are asking for a downtime, it is really a downtime. And and always the engineering community comes back heavily saying, hey, we cannot give you a downtime because we have a CS release, FC release. We have this product is launching pretty soon. If and the system which I manage, right, is a centric one, right? When we are talking about source code, it is centric, right? If you're talking about downtime there, it's the product launches may have a direct impact. So that's where zero downtime is needed. So you define your application whether zero downtime is one of the priority things when you're architecting the system or not. Some applications for sure it is needed. So design the systems accordingly and deploy the systems accordingly in the platforms where you can achieve that zero downtime. Some applications out there call it as near zero. Near zero is not zero, right? In my case, right, near zero obviously is handy, not than not having it. Because why I say that near zero is not zero, the name itself talks about it, but I'll give you an example as well. When you're running a build where you have we have to retrieve the source code, a zero downtime in the sense there is no downtime, so the build the source code can be pulled and the build can be compiled easy, right? But near zero, that means there is a service interruption, right? When you're pulling the source code, when you hit that near zero, that means that piece of software code, probably even after the retries, you cannot get it. What happens at that time is the whole build will fail because the source code which is reliant on compiling that missed. Or even worse is, if the compilation is successful for magical reasons, but it doesn't have the piece of software, that build is shipped out to the market. Even bigger problem, because some of the features won't even get enabled because the source code, the dependent source code is not part of the build, right? Things like that happen, and the customer satisfaction will be bad. Customers are the key for any companies to be successful. So if you lose that trust, we have a we have a challenging we have a challenge to address. That brings me to the deployment strategy. um, Various strategies out there in the market, things which I follow. I documented them. That's what you're seeing. Blue green deployment is heavy at Qualcomm. The reason behind that is, when you do your testing, right? You developed a new feature and it is working great. You did a path to prod deployment. That means you deployed it on non-prod, things worked, you tested it, you ran a functional test suite, performance test suite, load testing is done, you are confident, right? So you're releasing it into production. Everything is automated, so we believe that there are some gates in the process. You believe that yes, the on prod it is going to be successful, right? That's why you're releasing it in the first place. But still, right? How can we avoid catastrophics, right? Blue green deployment is a chance where you deploy, um, um, you gradually release it to the whole engineering community. That's a blue green deployment. You say green is the new deployment, blue is the existing one. You do a green deployment and do a failover, right? And the rollback can happen as well if the user community, with the new deployment, whoever is hitting the new deployment, if they ran into issues like that, you can roll back. So that's a capability which gives. That's why we are heavy into it. Rolling update canary releases may go in hand, where uh, you're doing a rolling upgrade. That means a subset of users will get it. You have some checks and balances there. Is the user who got the update happy about it? There is some gate there. Then slowly you release it. Canary releases, I'm just skipping the automated validation in a minute, but canary releases, they're tied as well, right? Like, so your traffic, say for example, 10% of the traffic is going to get this updated deployment. Then gradually increase it to 20%, 30%, 40%. Once it becomes 100%, that means general public got it, right? You can consider alpha, beta, general as well in the context where some set of users will get it, then the next set, then the general public release, right? Automated validations, it goes back to the one which I mentioned in the blue green deployment. Having testing, obviously everyone talks about, yes, testing is needed. Yes, it is needed. But having some health checks as part of the testing is needed, and so that you can do a path to prod deployment cleanly, right? You keep having the health checks as the problems arises even in the testing phase, but you need to qualify based on the health check whether this is a blocker for the production release or not. Defining that is the key, right? So having the thresholds, throttling based prevention is the one where you can achieve, or we can achieve what the goal is, reaching it into production without any flaw. um, Again, this is a continuation to that. What sort of measurable impacts you can define, these numbers are arbitrary. You can come up with your own based on your application needs. You can come up with what sort of impact you have when you are introducing these new processes into play, right? So rollback should be 100%. That's where the emphasis should be. Instant rollbacks are needed. if there is a problem. So you do the health checks, path to prod wise, health checks are in place. When you have a health check which failed and it is critical, automatically the rollback process should trigger, right? That is when you can call it as 100% success. Assume catastrophe, assume the failure first, and then design the system accordingly. Then we will be successful. Predictive analytics or the intelligence. We are bringing AI into the picture nowadays. So I'll give you one example where we know that as I spoke about read operations and write operations, for the reads, we want the user community to hit the nearest geo-replica site as per the design, right? But nowadays, probably we have seen some users hitting the primary. The user experience may not be that good, but still they're hitting the primaries for unknown reasons, or some issues while configuring their client-based setup. Things like that, we can proactively understand where they why they are coming to primaries first, so that we can alert ourselves, alert the community as well, saying that, hey, this is a misconfiguration at your client level. Things like that, we automated it through the alerting system. Without a human intervention, the bot can get into the client and fix the problem. Going back to that, predictive wise, I'm tying this with the user load traffic itself. So we know that, I'll give you with an example. I would say Thanksgiving is coming up, right? We know some of the applications out there, some of the websites out there will see heavy volume of traffic, right? During particular time, right? Which we know, with the common sense, we know that, right? So I hope they design the systems accordingly so that they're ready for that traffic, right? Similarly, in your industry, in your company, with your platform, it may not be that easy to predict, right? So we may need to have some predictive intelligence around it, with some practices with historical data. So running some machine learning on it, access logs, some application logs could be a good starting point where you run some machine learning exercise on that to understand what sort of load is coming during what time or what day or which week. If you run those metrics learning algorithms around it, you can predict when the traffic is going to when the increase of traffic is going to come, so that you can scale up the system accordingly, proactively, so that the stability of the system is maintained, user experience will be great, right? And bring in the AI now, right? So because of this machine learning exercise, artificial intelligence can play a role where based on the trend, because it's all about you input the data, with its own intelligence, it can predict some things, it can give you some insights which you may have missed, right? Things like that can be considered, and so that your system is proactive. Sometimes reactive is also okay, right? Because not every time will be 100% successful. Even for reactive things, okay, you're seeing the flood of traffic now. What do, right? Is your system designed to automatically auto scale as needed, right? Things like that should be considered while designing the system. Finally, well architected frameworks. You should have a migration strategy, proper migration strategy, whether it canary releases, gradual migrations, or blue-green deployments with the rollback strategies. Investing in observability is needed, right? Because health checks are the key. When you design the system with all these as the foundations, I'm sure the application is stable, it will be scalable and resilient as well. Key takeaways, as I mentioned, addressing scalability challenges. What sort of Azure solutions out there in the market, because it's Azure Innovative Hub. but in general, what solutions out there in the market which you can read and implement on your application. Resilience engineering, consider chaos engineering part of it. That's we learned a lot when our system breaks, based on the by doing a lot of iterative testing. Consider that. Zero downtime and deployments, if not already, consider it, please. Finally, with AI ML, predictive intelligence plays a huge role in bringing to bring in stability, and also optimize the performance. Thank you, everyone. Any questions?
Thank you so much, Vasdev. What a wonderful presentation, so well structured. I personally learned a lot. I don't see any questions to tell you the truth. So I just want to thank you for being here with us today. One of the best presentations I've ever seen, and I really enjoyed your narration and your style. So again, thank you so much.
Thank
Hope to
you.
see you again
It's a
in
pleasure.
another event of ours. Have a great one, my friend.
Thank you so much. It's a pleasure. Have a good
Bye
one. Bye bye.
bye. So yeah, uh, very informative presentation in reality, and we can observe how our speakers tend to explore innovation through their experiences. At least with this presentation of Vasdev, I was able to realize that while we're progressing through the evolution of every service, and I'm not talking about AI only, right? IT is a field that is always evolving. Always we have something new. Uh, so whatever we can get out of the new, the innovative or the cutting edge to help us improve our experiences day to day, is I think it's the best use of these evolutionary steps on each field, of course. And yeah, the observations I believe are going to be more and more because on one hand we may have challenges through these new services coming, of course, via AI. Many of them are unchecked, but we have the other part of the scale that people are evolving. People are able to learn better. People are able to use their time better and create amazing things. So many thanks to was there for this very informative session. I'm going to play a small intermission video, and we will move on to Srinivasan for the next session. Thank you, everyone. Right, we are already into our third session today. Hello, my friend. Hello, Srinivasan. How are you? Can you hear me? I think you're muted.
Yeah,
Perfect.
hey, hi, Constantinos. Yes, I can hear you.
Hi, hi. Thank you so much for joining us and submitting your session today. I think it's the first time we meet. Correct me if I'm wrong, but I think it's
Yeah,
the
this is the first time,
first
yes.
interaction we have. So tell me about you. What are you doing? What is your day to day? How you spend your days?
Yeah, yes. So I'm a product manager. So maybe there's a different angle I've sat through the last two presentations here. It's more technical heavy, but I'm a product manager. Day to day, I work for a company called Intuit in the US, and we are focused on solving financial problems for small medium businesses and consumers. So that's where I spend day in day out in terms of how I can tackle their problems. So that's where I come in.
Wow. Must be challenging, especially when there are piles of problems and you are called there to solve them, right?
Yeah, yes. Yeah. So again, like from my company, we have product suite that solves the full life cycle, like all the way from accounting to finance to payroll. So yeah, so we
Yeah,
touch a lot of the areas of small, medium business lives. So yeah, the breadth is large, and then there is a lot to look at in terms of solving their day-to-day
yeah,
problems.
yeah,
Yeah, it's an interesting space to be in.
yeah. And the software, I guess it is something in-house, right? If I understand correctly, it's an in-house software that you create, or it's a different
Uh,
case.
so it is in-house. We again use cloud services
Yeah,
um, for our build and deployment. But yeah, so we build a lot of it in-house. Again, it's a mix of things. We also are a global provider.
yeah,
So again, with finance and money movement, there is a lot of licenses and compliance involved.
yeah, yeah.
So it depends on, like, do we have the capabilities in those countries? Do we have the license in those countries? So based on what skill set, what competency, what licenses, and what compliance we have, we would take a different approach. So it is a mix of build, buy, and partner. So we have different flavors based on the countries that we operate in.
Understood, understood. Very interesting. This is the new era of business, and you are right on this brand new opportunities and cases. Are you located in the U.S., if I may ask, or are you located elsewhere?
I'm in
Where
the
you are?
US on the West Coast.
Great, 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 great. So I'm going to leave the stage to you and tell us all about what we are going to present to us today. Thank you for joining us. It's a pleasure to meet you, Srinivasan. The stage is yours, my friend.
Yeah, yes. I'm going to share screen, and you
Yeah.
can let me know. You're able to see a presentation? Okay. So I hope everyone is able to hear me loud and clear. So thanks a lot for taking this time to sit through these sessions. I know I sat through at least the one on Wednesday. It was great. And here is the second session that we're sitting through. And I hope you're able to see the presentation. I will get started, and then I can take questions at the end. So again, good morning, everyone. So I am Srinivasan Ravishankar. You can call me Srini. I am a senior staff product manager at Intuit. Um, so what do we do at Intuit? We are in the business. We have multiple product lines. The big product lines are on the small medium business side. We have two products. One is Mailchimp, which is more of trying to get customers, trying to get customers into small medium business hands. And the next is QuickBooks. So QuickBooks is primarily an accounting platform, but then it also does a lot of other day-to-day activities for small medium businesses around payments, payroll, and so on. So it's like it is meant to be the one-stop shop for small medium businesses to manage their end-to-end in terms of business needs. On the other side, we also have consumer facing applications. One is TurboTax. Again, anyone in the US would have faced that product. So that's an Intuit product, and we facilitate tax preparation for consumers and businesses, and it has different flavors. And the fourth is Credit Karma, which is sort of your personal companion in terms of managing your finances and so on. So these are the four big product lines. So today's focus, again, from my standpoint, is focused on the QuickBooks side of the product line, and how we're thinking about AI and automation in that area. So again, in our effort to serve millions of small medium businesses like QuickBooks and Mailchimp, our goal is to simplify finance and make confident decisions on behalf of our customers. Through that work, we've seen firsthand in the last couple of years, as AI has caught up, automation, AI, and policy governance can certainly transform the way small medium businesses manage risk, manage their day-to-day, their compliance, and cash flow. Today, I'll be basically walking through sort of a homegrown or Intuit grown architectural concept. Um, that I've applied to the AI Azure AI Copilot architecture. So what it does is it illustrates a policy-bound, explainable automation that can be designed to scale in the cloud. And this automation is going to power is expected, has high potential to power many of the day-to-day tasks of small medium businesses. So a lot of what I present today will be based on very recent product learnings that I've had at Intuit, and also some industry research that we have done from our own end, as we have understood in terms of what other companies, what the market is doing towards making lives better for small medium businesses. So it would be driven by both internal learnings as well as industry research. Yeah. So why this matters? So let's start by looking at why this problem matters so much, especially in the small medium business lens. So most small medium businesses, the way that we define small medium businesses again is again there are different definitions, but a small medium business is any company that's probably in the first few years of inception, and they anywhere exist between 1 to 9, 0 to 9 in terms of employees, right? So there could be solopreneurs who are just one owner, and then they could have a small set of employees, but anywhere in the 1 to 9 range is sort of defines in terms of what a small medium business is. So obviously they don't have large finance teams or IT departments to manage the software or build software on their own, but they do have different use cases to solve for. One is invoice reconciliation, which is like, I'm a small medium business, I'm providing a service to someone, I send out invoices, I want to get paid on those invoices, and once I get paid, again I would have to reconcile all those invoices to tie back to my accounting and bookkeeping systems. The next is payroll. Again, I have employees, I want to pay them, I need a secure way to pay them, and I need to make sure that they get paid on time, while at the same time I'm able to efficiently manage cash flows and have payroll taken care of. The other could be bank matching, where again, at the end of the day, I'm getting paid into my banking system, I get paid out of the banking system, and a lot of matching needs to happen so that I can keep away from any manual work. But believe it or not, today a lot of this is manual, and while the action is accurate, it is heavily human dependent, and it is also slow because of all the numbers that people have to crunch through, especially small medium businesses who have very low manpower. And it goes without saying that every minute spent on these tasks is time spent not spent on doing the real work that small medium businesses want, which is around like growing their business. The second big problem that exists is tool fragmentation. So again, through our own internal research at Intuit, so what we've understood is a typical small medium business, while there is every company out there that is trying to be that one-stop shop for these businesses, it is not that easy for these businesses, right? So they have to juggle between 15 and 20 disconnected apps or systems. There would be one system for invoicing, there could be one for expense tracking, there's another system for payroll, there's another for CRM, and so on. And what comes along with it is people have to like manage and juggle between these systems. Data is sort of siloed to those systems as well, and each has its own logic. But what this results in is it results in duplication, it results in a lot of inconsistencies, and there is a lot of extra work to again tie and reconcile between these systems. And of course, last but not the least, there is a heavy compliance burden. Meeting standards across Europe and US, for example, you have GDPR for data privacy, you have like PCI compliance for cards, and these are not optional. Like while they take payments, while they want to keep data of customers in their systems, it's incredibly demanding when you don't have the right compliance specialists on staff. And especially when you're a small medium business with very low employees, all of this is going to be very difficult for such companies to manage. So the overall challenge is just not about automating these flows, right? It's also about creating automation that's explainable to government agencies. You also need to be policy driven to make sure that you're continuously, every transaction is like compliance bound, and it is also trustworthy. So where humans can still stay in control, it is not like we will completely let it in the hands of AI systems to manage everything, but humans can still stay in control. And that's the foundation of what we have attempted to do at Intuit in the recent years, and what I'm here to share. So now that we've seen in terms of why finance automation is so critical for small medium businesses, let's look at how we approach it. So at Intuit, again, our goal has been to bring enterprise grade capabilities to small medium businesses, right? But in a way that preserves control, transparency, and trust for these businesses. So we do this through what we call, again, a very recent framework. It's not a public framework. It's more of our own mental model of how we approach a system that blends AI intelligence with policy-driven oversight. So at its core, what we call this framework as, or what I call this framework as, is called as a PPAC framework. It's about perceive, plan, act, and check. And as we go through the slides, future slides, I will also be able to take up very simple examples in terms of how we apply, how this framework would come to life. So it in its very simple sense, it's basically a continuous loop that ensures that automation isn't static. Right? It looks into data. It understands in terms of what actions need to be taken through the policies that are set up. It takes action. It implements those actions, and also it continuously learns and adapts so that the business rules and the actions remain relevant, right? So then there is also staged autonomy, because like once AI comes in, it's not like we're able to scale up these systems overnight and put it into action, because uh, there is a learning cycle even for companies to understand if is it doing the right thing or is it not doing the right thing. So that's where staged economy comes in. We see it as a maturity model where automation earns trust gradually. So we would start in shadow mode, then we move into an assisted mode to see what's happening. Then it's guarded, and finally we let it go into full autonomy once we have enough data and confidence to say that it is performing well within the guardrails of compliance and it is delivering tangible benefit for our customers. To again, in all of this, again, to ensure we always stay compliant while implementing these automations, we would have policy guardrails. There'll be a three-tier layer that I'll be discussing that governs the architecture, infrastructure, the business rules, and the regulatory controls, and ensure that they're all applied in every stage of the system. And also because while I know there's a lot of topic and discussion around human judgment in all of these flows, we still don't see that human judgment is we see human judgment as irreplaceable at this time. So there'll be exceptions again in these flows as we learn and adapt. We want the systems to adapt. There'll be a lot of human intervention to tell the systems in terms of what the right and wrong is. So exception flows, workflows again keep people in the loop with complete audit trails for transparency and for us to look back in terms of like how the system has evolved. So together, these pillars here create measurable business impact as we see it. Faster month-end closes, fewer errors in terms of invoice reconciliation, payroll, and better cash flow visibility overall for our small medium businesses. Moving on. So how has finance automation evolved over the years? So this basically just gives a picture in terms of like where we started, what happened several years ago versus what came next, and where we are right now. To understand why this moment in automation is so transformative, it helps to like step through and look at how we got here overall. So at least in our minds, in my mind, the way that I see it is we began in the ERP era. Systems were built for control and compliance. They were powerful, but they were sort of rigid. Again, they were like large systems, expensive, and generally out of reach of small, medium businesses in terms of the capital that they operate with. Then came the SaaS revolution, making software as a service available that put all of these software at easier access for these small, medium businesses. So what came about was it made finance automation accessible, right? For the first time, SMBs could automate key processes without massive infrastructure or investments. But these systems still followed like very fixed rules. Like they were not able to adapt quickly. They still needed a lot more human intervention to be able to keep them live and running and compliant. So now we've entered, obviously in very recent years, into the era of AI intelligence, where automation isn't static anymore. So systems can basically learn context, they can detect changing patterns, and even explain as to why they made certain decisions for us to like understand in terms of how the system was thinking as it took certain actions, right? So that shift we are seeing more and more in the last year or two has been more real and has been delivering measurable impact. In financial operations, for example, modern AI-driven systems have boosted fraud detection rates. Fraud and risk detection has been a heavy area where a lot of innovation is going, and a lot of AI is getting involved. I've seen industry reports where there have been detection rates have significantly improved, but somewhere from 56% to over 90%, and also at the same time, false positives have reduced significantly, which means there is a reduced friction for genuine customers. So what's powerful here is that AI doesn't, again, we don't see just replacing human work. We see that it elevates it or it complements human work, and it helps teams and in turn makes customers like make faster, more accurate, and more trusted financial decisions as they scale and as they grow. And this sort of sets the stage in terms of what we want to look up next, which is an architectural foundation that makes governed, explainable AI automation possible in today's world. So now that you've seen in terms of how AI automation is powerful, let's also look at in terms of some of the principles that we can be realized using Azure AI services and capabilities. So I also want to maybe give a disclaimer. So because I'm coming with a product manager angle, I'm going to keep it. It'll be a fair mix of maybe business and technical focus, and I'll I'll keep it a level where like we think purely from a customer lens in terms of how we are thinking through this. So while Intuit's own systems are like platform agnostic, so what do I mean by that is like we are not heavily bent or leaning towards a single technology. We see that the same design principles that we discuss here that I'll be presenting here can be translated into Azure or into any of the other cloud providers, or also into any of the other automation tools that are coming about. So for instance, like cognitive services can handle document and text understanding. We can think of invoices, receipts, and expense notes that SMBs manage on a day-to-day. All can be extracted, or information can be extracted from them and contextualized automatically. Right. So next is logic apps, for example. Then they connect those data flows. They could orchestrate approval flows. They could orchestrate reconciliations and also update information across a different finance systems with low code flexibility. The third is like an example of in the Azure world. Again, there could be similar technologies in other cloud platforms as well. But then it comes to Azure Functions. They provide sort of the compute backbone. So they could be event-driven serverless execution that allows to take those actual actions in terms of money movement, payments, and so on. And again, Azure machine learning could power the intelligence layer behind all of these systems, right? So because there is a continuous learning cycle, these models could help with categorization, anomaly detection, forecasting, and also power the whole cycle of trying to go back and provide feedback so that the system gets better on a daily, on a weekly basis. So when combined, these services could demonstrate how a policy-bound automation framework can run securely, run transparently, and at scale with explainability to compliance built in through every stage of the process. So everything we've discussed so far. So this slide is probably that sort of the homegrown or my own view of the PPAC framework, and we will go into that. So everything we've discussed so far, from evolution to architecture, comes together in what I call as the PPAC framework. I break it down into 4 parts. It's perceive, plan, act, and check. Right. So this is more than a process. I see it as to be the foundation of intelligent policy-bound automation. It ensures that every action that the system takes is informed by the right data. It is governed by policy, and it improves on feedback. So that's what this 4-stage process is going to look at. Let's walk through it and let's understand like more in a greater level of depth in terms of what each stage means. So perceive is all about awareness. Right? The systems continuously gather data. There are transactions happening. There are so many data points and actions that are happening on a day-to-day basis. So it's meant to gather data from multiple sources. Again, examples being invoices, bank feeds, emails, other SMB behavioral patterns, to understand what's happening in real time for the customer. Right. The next is about the next is about planning, is where the intelligence meets the governance aspects. Right. The system will have to apply its policies. So they look at the data, but then now they have to apply its policies against the data. It could be policies, it could be business rules, it could be any other optimization logic that needs to be applied for the best actions to take. Right. So then we come into the act layer. The act stage is where those perceived or planned actions are executed securely and reliably. So this is where all the API automation, the API calls will come in. So examples could be transactions are processed in the right way with rollback. If needed to roll back, there are approval workflows are kicked in. There are complete audit trails in terms of any actions that are being taken, and ensure that no action ever occurs without accountability to the action that was taken. And so And finally, we have the check layer. The check is basically measuring the outcomes of those actions, right? So because every action in our hope and intent is to make the lives better for small, medium businesses. So we want to be able to measure those outcomes, detect any anomalies that are happening, and feed that insight back into the system itself. So this is how automation learns and adapts over time. And this is how we are able to move away from the rigid frameworks that have been in the past years, and move to a more real-time system. So at least in my mind, the beauty of the framework is that it keeps humans in control while enabling machines to learn responsibly, and take relevant actions, right? Automation sort of becomes not just efficient but explainable in all of this, and a trusted partner in financial operations, especially where money is involved, and that's the bread and butter of what everyone out there is trying to do. So now we are going to go. I'm just going to take a further step into like what does it mean through each stage of the framework. So let's start with the first stage of the PPAC life cycle, which is the perceive. Right. So everything again begins with data. Right. So AI is as good as the data that powers it. The quality of automation depends entirely on how well the system perceives and interprets the different inputs that it has. Again, this is common sense for anyone who's involved in the AI world. But so we deal with three main types of data. The first is the structured data in itself. We want clean, well-formatted information that comes through APIs from the different systems, like we already discussed, like accounting systems, payroll, and banking platforms. This gives basically the real-time visibility into transactions, balances, and eliminating any delays in terms of getting the right data in place. Second is semi-structured data. Again, there could be things in terms of PDS invoices, receipts, or statements. These aren't perfect tables to say. Like a lot of the PDF invoices that are managed today are in PDF format. Again, each company has their own format, which means it's not in a perfect table or a perfect view, which means some interpretation needs to be done to it. But with AI-based document processing, we can extract the relevant fields from these invoices, such as vendor name, the amount to pay, the tax involved, even in some cases, the bank accounts that we're paying to, with roughly very high accuracy. As in some scenarios, we've seen 90% accuracy in terms of extraction. So that what this translates to, that means fewer manual touch points and faster close cycles. And the third is again goes into unstructured data. The data obviously is known to be very messy there, but has very valuable information. So this could be like in terms of ad hoc emails, memos, meeting notes, chat messages that again small medium businesses would see. Again, a 31% improvement in comprehension versus older keyword themes, keyword systems is what we've seen. So when all of this is combined, all the different data layers here are combined, the output is a clean, context-rich ledger, right? Every event, every transaction is ready for policy validation and automation, which is the next stage that we'll see. So in very simple terms, the perceive stage makes sure that automation starts with the ground truth for small, medium businesses. If the perception is accurate, then every decision downstream is expected to be more reliable, more auditable, and more explainable, and will ultimately enable us to deliver the improvements that we want to deliver to our small, medium businesses. So once the system has gone and perceived the data correctly, so what comes next is the plan stage. The plan stage is where we decide on what actions to take. So we have certain data, we have interpreted that data. So here is an understanding in terms of what kind of actions that we would want to take against the perception that we've had. So in this stage, we are translating information into intelligent, policy-bound decisions. The goal here isn't just about speed, right? It's also about confidence. It's to make sure that we're taking the right decisions and not trading off the right decisions over the speed at which we want to take those decisions. So every automated decision here, again, I think in every slide going forward, we'll be discussing, but because there is a lot of compliance around money movement and where money is involved, so although we are going to be using AI to automate these decisions, it's always important to make sure that although AI is taking those decisions, we have enough judgment and enough information for us to explain those decisions to any regulatory authorities that we would have to eventually answer to, right? So we start with a rules engine that basically blends deterministic logic, very as simple as like if else statements, with machine learning outputs. Right. So while the system follows established business rules, it also adapts to context, right? For example, It could be around identifying exceptions. There are static rules that might miss. Then comes compliance validation. This is where this is the guardrail layer, right? So we to make sure that in an effort to make decisions, we are not missing out on compliance. So every processed action is checked against internal policies as well as external regulations like PCI or SOC compliance and so on. So this ensures automation doesn't drift from policy intent, no matter how complex the data we are processing. The third is finance optimization. Sorry. So this is where AI helps with improved timing and accuracy, right? By analyzing the historical trends and the real-time balances, the system can forecast in terms of what cash position applies to these sub-merchants. We've also seen very high accuracy there in the order of 87%. And it enables for smarter payment scheduling and liquidity management. Because again, small medium businesses, one of the biggest problems that small medium business faces are all around cash flows. Like, how efficiently can I manage cash flows in terms of money coming in? To what extent I can keep the money to myself to the maximum time before I'm having to pay out, and let the money go out, right? So that's the most important life cycle that any small medium business wants to manage. But through the finance optimization and through the learnings that we could get, we could probably efficiently manage those cycles. So finally, again, it comes to decision traceability, and this ensures accountability in the overall process, right? So every rule, model version, and outcome is logged, so that when auditors or regulators or stakeholders ask, hey, why did the system do this, or why did the system do that? What has changed? There is a clean way for us to be able to go and explain, this is what has happened, for us to be able to explain these decisions, right? So in short, the plan stage turns automation into intelligence, and it leads to a fast, compliant, and completely explainable process and actions that we will be taking. So once the system knows what to do, right? So the plan has given an indication in terms of what the system needs to do. The next step is to actually take the action itself, right? So, and that's where the act stage comes in, to carry out those decisions safely and consistently. So think of this as the operational heartbeat of this overall framework, right? Because this is where real things are happening. So far, we have perceived and understood, we have decided what to do, but this is where the actual action is happening on the ground. So it's where basically intelligence translates into action, right? So it starts with secure transactions, right? So, and this is where money movement is involved, and it's probably the most critical piece of anything in a small medium business's life. So every payment, every adjustment, or every approval passes through multi-factor authentication, right? To make sure that the security is put in place and it is digitally signed, ensuring compliance with PCI and data protection standards. So that essentially means confidence for our financial and accounting teams to make sure that they are able to approve and acknowledge the system is doing the right things with money. Sorry. So then we have event-driven processing. So in plain terms, each transaction is handled like its own small package, right? So we call, on technical terms, the atomicity of transactions. So if one fails, the whole system shouldn't fail. The system should be able to retry until it succeeds. That also, at the same time, the system should also avoid any duplicates and ensure nothing slips through the cracks as these transactions are processed in thousands or millions on a daily basis across a larger small medium business customer base. Next comes to atomic execution. Takes reliability a step further. Each workflow is an all or nothing action, right? So it either completes fully or it is able to reverse gracefully and cleanly, and there is no half-posted journal entry or nowhere in the flow there's an intermediate action that again would lead to exceptions and a lot more manual effort and could corrupt the system overall. So finally is again coming back, it's immutable audit trail, which captures everything that was done, right? Or what happened, when did it happen, and why did it happen. Again, this goes back to explainability to auditors and business leaders. So when you put all these elements together, that's where governed execution isn't just about control. It's overall about trust in these systems itself, in these automation systems. It gives basically the teams the assurance that automation won't compromise accuracy or compliance even at scale. So the final step in the PPAC cycle is the check process, right? So it's about verification and learning. So this is where automation itself is held accountable. So it verifies what it did, learns from the results, and becomes better with every cycle. right? So let's break this down. First again is automated reconciliation. So means the systems constantly compares what actually happened against what was expected to happen. Right. So if a payment, posting, or balance doesn't match, it flags that discrepancy instantly, so that we're able to go back and review and see as to where the failure happened and take any corrective actions. We don't have to wait for end of month reviews to make bulk actions to be taken. So we expect it to be more real time for us to review and react. Next is anomaly detection. Here, machine learning models are expected to pull in their might. So for patterns that don't fit normal behavior, like duplicate payments, out of cycle invoices, or suspicious approvals that could be happening, the false positive rate we are able to drive below 5%. So teams only see the signals that matter and is important for the business. With real-time observability, everything is visible, right, to all the stakeholders. So dashboards show the transaction flows, system health, and exception patterns. So this transparency is key for both technical and business teams to understand what's happening and react quickly to any corrective actions that they need to take. Finally, it comes to continuous improvement. The human feedback we still see is essential here. So when exceptions are resolved or rules are adjusted, that incites feedback into the system, and that would lead to updating models and policies. But over time, the automation doesn't just perform well; it overall performs better. So this is what makes intelligent decisions like sustainable, or the automation sustainable. It doesn't just act. I think the learning is key, which I know is, again, goes without saying in the AI world. It doesn't just scale, it also governs itself responsibly. So how does everything that we've discussed together come sort of in practice, right? So this diagram basically shows a reference architecture that supports the PPAC framework, right? So a layered approach that brings enterprise grade reliability to SMB scale automation. So we start with the user interface layer. It could be web, mobile, or low code experiences. This is how finance and operations teams interact with the system, the automation system, right? It's designed to be simple and transparent, so automation feels like a partner, and not something that's frightening or not a black box, right? So next is the API gateway, which sort of handles the authentication, version control, and request limits. It's the traffic controller, ensuring every interaction with the systems behind is sort of secure and predictable. The third is the orchestration layer itself, which coordinates the different workflows, right? So think of it as a conductor. It connects tasks, manages dependencies, and ensures that every process runs smoothly end to end as automation happens. The fourth is a compute layer, is where the real work happens. It could be serverless event-driven execution that scales automatically as transactions come in, as volumes go up and down during the day or during end of month cycles, and so on. Then we have the AI and data layer itself, which is the brain of the system. This is where the models interpret data, detect anomalies, and predict cash flows or payment trends. Then comes the integration layer, which connects to all the different systems that we spoke about, which would be the source of truth data points. It could be banks, it could be accounting tools, it could be other compliance platforms that help us maintain the consistency across the entire ecosystem. And finally, at the foundation is the security layer itself, which protects everything. It could be identity management, encryption of data, and continuous monitoring that ensures governance isn't an add-on or is not an afterthought, but it is built into every transaction. So together, these layers create systems that are both intelligent and are trustworthy for us to build scalable automation systems for business life. So again, I know so far we've discussed like sort of a concept that could apply to any use case that we pick up, but was my attempt at explaining with a more concrete example, right? So it sort of brings the architecture to life in terms of a document processing pipeline. So every finance workflow begins with documents, right? So there are invoices that are coming in. There are invoices that are going out. There are receipts that are coming in against those paid invoices. There are statements. Each one contains important details that must be captured accurately and governed properly, right? So the process starts with ingestion. Documents come in through multiple channels, emails, file uploads, or APIs, and are automatically captured for processing. No manual forwarding or manual uploads in this case. They could be powered by sort of set email accounts that could be automated to capture anything that comes in and automatically translate it to a structured data. So next, the system classifies each document type using a combination of computer vision models and business rules. Is it an invoice? Is it a purchase order? Is it a receipt? With around 96% accuracy, the systems knows exactly how to route it correctly and what the downstream actions could be. Right. So then it would be the extract and validate stage. So here AI identifies key fields from this one. It's about vendor names, totals, tax lines. So it's doing the interpretation of the data that has come in. And it is also going to cross check with prior transactions and trusted data sources. So this step is all about the trust that is involved. And after that, we enrich and store this data, right? So it's basically the entire data processing pipeline of data coming in and getting it stored for subsequent processing. So the data is enhanced with context. It could be vendor matching, matching it to past vendor invoices that have come in. Account categorization is another example where we're categorizing banking transactions or account information, and confidence scoring. It's then securely stored, ready for reconciliation or further processing. Right. So this is a great example of how an intelligent automation and human oversight coexist. It's sort of fast, accurate, and fully traceable back. So now that we've seen the document processing pipeline captures, classifies, and validates information, the next question is, where does all this data go? Like, where does it live? And how do we ensure it stays accurate, compliant, and trustworthy? So that's where the data architecture and the quality framework comes in. It serves as a backbone that makes intelligent automation reliable and auditable downstream, right? So add into it, again, we focus on platform agnostic principles. But for today's discussion, I will again illustrate in terms of how some of these design principles can apply to Azure data and storage ecosystems. But the goal overall is simple, right? So build a foundation that balances performance, cost, and compliance while maintaining very good data quality. So what could a storage strategy look like? Again, Azure SQL database provides transaction level storage. It's fully asset compliant, ensures financial accuracy and consistent reconciliation across ledgers. The Azure Cosmos DB would handle the document storage here. It's again a flexible scheme agnostic of it's a flexible scheme agnostic environment, ideal for invoices, receipts, and semi-structured data. The next is the Azure Blob Storage. Again, could help with managing files more efficiently, frequently used in data lives and hot storage for speed, while older or closed period data moves automatically to cooler, lower cost archives. And the next is the Azure Data Explorer. So this basically supports analytical and time series storage of information, all right, capturing logs and trends that will help us with forecasting and anomaly detection. So moving on to the data quality framework. So every data set is validated against business rules and schemes and schemas, catching errors before they propagate downstream. Automated duplication removes redundancy or conflicting entries. There is also continuous profiling that happens, and monitoring maintain data health and flags anomalies in almost in real time or in near real time, right? And underlying all of this is a master data management itself, which ensures alignment across core entities, such as vendors, accounts, and cost centers. So every report, every forecast, every decision is based on consistent truth. So when we combine all of these layers, storage, quality, governance, you create a system that's transparent, again, that's compliant by design, and trusted data essentially creates trusted automation for us. So moving on. So one of the key reasons, again, this framework works at scale is because it's not just intelligent. Again, it's governed, right? So we want governance baked in. So this is the three-layer approach to governance that I'd already called out. So the first is the compliance layer itself, right? This manages everything required by regulation, from data retention to PII masking to cross-border restrictions. It also ensures that we stay compliant no matter where the data sits or flows or who processes that data. The next is the business rules layer. This is where the operational policies live, right? The things like are certain transactions going beyond certain amount levels? So then let's kick on the approval workflows, the budget control rules that we want to put in place, the timing windows for payments that we want to manage. So all those business logic sits in the business rules layer. The third is the infrastructure layer itself, which provides technical safeguards like encryption, private endpoints, and data residency controls, so that security is not an afterthought. All of this is managed through a principle we call the policy as code. That means every policy is written, versioned, and tested just like software. So we can run A/B tests on those roles. We roll them back instantly if something doesn't work, and keep a full change history so that we are able to audit and understand how systems are reacting and what's causing the changes into the system. The result of this is powerful, right? So governance becomes a living system through these automation systems. It adapts as business evolves, but never loses its integrity, right? It's automation that's again explainable and compliant right from the start. This goes into the sort of the staged economy that we spoke about. Adoption always starts with trust, right? So we want to drive trust into the system, and that's where the staged autonomy model comes in. Um, uh, Quickly running through the 4 layers of this model, we start with shadow mode. It typically is the first 1 or 2 months. Here, the system observes human actions and provides recommendations, but people still execute those tasks. It's sort of the discovery phase of the automation system itself. So you learn what the system sees and how it behaves. Then we move into the assisted mode. Again, around 3 or 4 months in is when this could happen. The system starts to handle routine, repetitive actions. Humans still approve or review those significant actions, so governance and learning sort of stay intact. After that comes the guarded mode, right? About 5 to 6 months in, by now the systems has earned some trust in terms of the action that it is taking. It operates independently but flags exceptions for human review so that humans are still kept when the system sees deviation. Finally, we reach full autonomy, and that's where it's typically, we've seen at least in a couple of use cases, it's like 7 months or more, where the automation now manages end-to-end processes reliably. Humans shift their focus from doing tasks to auditing policies, monitoring outcomes, and continuously improving the models. Each stage is sort of deliberate and measurable, and automation scales not just by flipping a switch, but by earning trust one milestone, each milestone at a time. Going into security and compliance, again, our push is to not keep this as a last step in the last stage or last step in the design. We want it to be woven into through every layer of it, right? So we often say at Intuit that trust is our most important feature, because customers are putting their cash flow lives and their business lives in our hands, and so that applies just as much to the architecture as to the user experience that we want to offer them. So the foundation is a zero trust architecture. Nothing is implicitly trusted. Every service, every connection, every user has to be authenticated explicitly. Using managed identities eliminates stored credentials, and private endpoints sort of isolate the traffic so data never traverses like open networks. Access control, here we enforce a least privilege access through role-based permissions and conditional access policy. So we have roles baked into all the product lines that we spoke about that make sure that the people with the right authentication and the authorization are able to take the right actions, and it's not like open to anyone breaching into the systems and taking unrequired actions. Then it's about data protection. So everything is encrypted, both in transit and at rest. Sensitive fields are tokenized when it especially goes into any analysis pipelines. We also make sure there is data loss prevention policies to stop accident exposure before it happens. Again, on the compliance world, there are very strict regulations around how long we should keep data for. There are like 7-year guidelines for certain use cases and so on. So we also have to go by strict data production and data storage guidelines. Finally comes compliance operations. We need to make sure that it runs continuously. Automated scan checks configurations against frameworks like SOC 2 or GDPR. The results flow into real-time dashboards. So when auditors ask for evidence, we're able to get those data points and are able to provide them to ensure that we are able to produce traceability and make sure that we are showing them that we are compliant in these systems. So the result in all of this is an environment where security and innovation coexist, right? Teams can move fast because controls move with them, and they are again automated, auditable, and adaptive in nature. Moving on. So everything we've covered so far in terms of the PPAC framework, the data integrity, the guardrails, the metrics you see on this slide again comes from a mix of industry studies and comparable implementation, right? All of this is not purely Intuit alone, but this was again when we were trying to learn and understand in terms of what's happening in the market, what are some of the reports or studies that were done. We were trying to understand in terms of like what the general understanding of some of the improvements the market is seeing, right? So let's start with operational efficiency. Again, organizations, based on our own assessment, that have adopted automated invoice and reconciliation workflows have reduced invoice processing time by nearly 87%, right? So that's anywhere from 15 minutes down to about 2 minutes per invoice is what they've been able to see through the automation process of invoice reconciliation. Reconciliation, again, which used to take about 4 hours a day, now takes roughly 30 minutes for these businesses. That means finance teams can focus on analysis and insights rather than like data entry. So next, let's look at cost and ROI. Again, automation lowers manual labor costs by more than 70%, and most companies are able to recover their investment. Obviously, AI requires an initial investment, but we've seen industry studies to say that they've been able to recover their investment in an 8 to 12 month time frame. At the same time, error rates are dropping by over 90%, saving hundreds of staff hours that would otherwise go into fixing mismatches and reworking and doing manual reconciliation. And perhaps the most important or meaningful is improvement in financial predictability and accuracy in all of this, right? So with cleaner data and consistent policy enforcement, organizations can see cash flow predictability improve by about 40%, which directly strengthens working capital management for these businesses. Again, late payment fees could reduce because of intelligent on automated processing that's happening. We could avoid if there are payment flows that are involved where we are paying like regulatory authorities or like other vendors, and if there are late payment fees involved, this whole automation can help avoid late payment fees, and that also again goes back into improving the cash flow management and the cash flow lives of these small medium businesses, right? So when you put all these outcomes together, automation sort of stops being a back office optimization project, right? So it's not like a side project and becomes a strategic enabler and of confidence and growth for small medium businesses. So now next, let's look at how organizations actually get there, right? So what it takes to deploy automation more responsibly, align teams, and manage change effectively. So that's sort of the delivery playbook. So so now we've seen all the different pieces of the puzzle, but let's see how we could deliver and how it delivers measurable impact and how it governs securely, right? So uh, uh, the final piece in all of this is putting together this is the organizational readiness and how teams actually implement this successfully, right? So because no matter how advanced the technology is, if automation success ultimately depends on people, it depends on people, processes, and discipline to make sure the overall success of that technology that's being implemented. So here is again my view of what a delivery playbook could look like. First is the data foundation, right? So again, it's tempting to jump straight into automation, but clean data and unifying the data is going to deliver the best power and best outcomes when it comes to making downstream systems smarter and more efficient. So companies that establish a strong master data management often see up to a threefold improvement in accuracy and ROI, simply because the automation starts from real and clean truth. Second, it comes to starting small and iterating, right? Again, we saw through the whole framework, there is probably automation that could be implemented in every stage of the cycle. So where do we start? Like it's going to take years and iterations for us to get a full-blown system in place. But again, that's not the intent. I think we should not try to automate everything at once, right? So we should begin with a focused MVP, like invoice processing or reconciliation, pick up a use case, again, understand in terms of what are the different stages to enable that use case end to end, and go start automating each stage of that use case, right? So that you start small, you see where the most impact could be, start automating there. So that way it's incremental, it's easier to learn and adapt and get better over time, and rather like wait to build a master system for that takes years, by which the whole world has gone past, right? So so it's important to be focused on an MVP, measure the results, and scale from there, right? Quick wins, important wins create momentum, and each iteration builds trust in the overall system. Third is the governance framework itself. So establish the rules early, how often policies are reviewed, how exceptions are handled, and who owns compliance monitoring all becomes important, right? So compliance cannot be an afterthought, because if a system is live and if it's already starting to manage and automate transactions, while it's not measurable or it is not guardrailed by the compliance systems, then it opens up to regulatory action or misses in the future. So it's important to governance framework. Think about it and bake it into the flows right from the start, however small the flow that you're building in. The fourth is about change management and leadership. Again, people are very used to doing things the old way. It's not easy to bring about change. And that's where it becomes so automation I see as a cultural change over a technical one. Again, even today when we talk to customers, as much as the improvements that we would be offering through some automation, they are so comfortable in the old ways of doing things. So it takes a lot of effort and motivation to move people over. So that's where programs with visible executive sponsorship, and there is leadership oversight, and there is leadership focus and push, is very important to bring about automation changes both within the systems, um, and that would be ultimately needed for the overall success of these programs that we bring about, right? So we should invest in communication, training, and feedback loops, because these are the levers that will help us to drive sustained success. And finally, the human oversight in all of this, right? So automation doesn't remove people. I think it's important to make people understand that it elevates them, and human judgment is very important as we scale these systems and make these systems better and better. So in short, I think the successful automation starts with people. It's guided by data, and it is protected by governance, is what we are trying to push for. So once you have the readiness and the leadership alignment in place, what comes next is what is looking ahead, right? So how these technologies are evolving. Obviously, there is innovation that's happening on a day-to-day basis. So what does it mean to evolve, and what are some of the newer things that are coming about, right? So looking forward, again, I see finance automation isn't just getting smarter, right? It's getting more responsible. So large language models, I expect, will let teams define policies in plain language and get decisions with clear explanations, right? We could be moving from even low code to no code setups, where teams that are not technical heavy are able to just speak to the system in natural language, and that translates those policies from plain language into policies, into decisions, and so on. Again, blockchain, I know, is another emerging technology, and we see that extend trust across partners with shared tamper-proof audit trails, and smart contract settlements. The third is edge computing. Again, internet is not a luxury to everyone in the world, in every part of the world. So that's where I think edge computing becomes more important, where decisions are right to the point of the transaction, right? It's much closer to the customer than to the backend systems, which allows for fast, resilient, even when connectivity is limited or not available. And AI governance will keep tightening. We expect more requirements as governments also start to learn, more fairness testing, more explainability required, and sort of robust appeal paths when things are not going as planned. So the bottom line here is success comes from getting these fundamentals right. Start with a solid data foundation and explicit policy guardrails. Scale through a staged economy that we discussed, so that trust goes with capability, and it's not like overnight we turn on systems which would be more difficult for us to understand and interpret. Maintain human oversight and real-time monitoring to keep systems accountable, and measure ROI early, right? So all of this is being done to improve the lives of the businesses, and improve the lives of our customers. So it's important for us to like build our own confidence that this is delivering the right outcome. So that's where we should measure ROI early in terms of efficiency that it's delivering, accuracy that it's delivering, and predictability, so you can reinvest where impact is highest. Right. So innovation will keep moving quickly, but trust and governance are what makes it sustainable in the lives of our businesses. So again, as we wrap up, I want to leave with a simple idea, right? So we saw so much. What I see as the key takeaways are the true innovation is in finance automation isn't just in machine learning models or new frameworks, right? It's about building systems that people can trust. Because as much as we build, if our customers are not able to build trust into those systems, then I think the effort is lost. Right? Technology can handle the scale, the complexity, and the data, but I think governance, transparency, and human judgment are what makes the technology sustainable. The PPAC lifecycle that we spoke about, the perceive, plan, act, and check, it doesn't really end, right? It's a living loop that keeps automation aligned with business intent and human values. All right. So if there's one takeaway from today, it's this, right? So when automation is governed, explainable, and designed for people, it becomes a force of confidence, not just efficiency, and it will truly transform our customers' lives. So again, thank you for all your time. It's been a pleasure sharing my perspective from a product management lens. Again, applying Azure overlap to it, and sharing my perspectives with you in terms of like how I be perceived as a framework to provide and make customer lives better, because that's the end outcome of every business, right? So hope this was helpful. Again, I'm available on LinkedIn, and happy to chat in any further conversations. Thanks a lot.
Thank you, Srinivasan. Wow, what an interesting approach. I really loved your approach and how you uh, um, persisted on security and best practices regarding the most important part of your um, practice, let's say. Also, I like the fact that you insisted that intelligence systems are intelligence as long as people are managing them and providing context and this type of intelligence at the end of the day. That's really important and really encouraging to see that our understanding is shifting to the correct direction. Thank you so much for your really insightful approach and session. I hope we will see you again. I don't see any questions right now, so thank you so much. Have a great one.
Yeah,
Nice to
thank
meet
you
you,
very
my
much,
friend.
Constantine, for having me on this one. And it was a pleasure walking through all of this and sharing my insights into this one. Thanks a lot. Thanks everyone.
Thank you. Thank you so much. Bye bye. Great. Today, I can say that today it was a very interesting collection of speakers. I haven't heard these sessions before, so it was really interesting for me as well to hear opinions, to hear ideas, to hear experience through the field, from technical to business, and really the gap doesn't exist. There is no gap there. Okay, we're living in the same space, in the same era, and this era defines also our space in the information technology uh, field. Many can say science, but okay, I will say field just in case. Uh, I really appreciated all of our speakers and all the ideas and approaches were amazing for me, from the technical ones up to the last one with a product manager that really expressed the next level of how we should perceive modern modern deployments, modern technology delivery. That's the word I was thinking. So let me have a quick intermission and I will come back to say goodbye. Right. So that's it for today. The first 2 days of our Azure Innovators session has come to an end. This is a group of session, let's say, for the 22nd and the 24th of October. There is a second group, a second set. It's going to be on the 5th and the 7th of November. So I hope to see everyone there. Really interesting sessions again with so much to hear and learn from our beloved speakers. Thank you for everyone being here today, and for those that watch the videos later. I really hope you enjoy them. So long, at our next meeting. I'm Konstantinos, and have a great one, everyone. Bye bye.